nur grün, sondern sie sind grüner. Everything apparently is on automatic control. Und wir hoffen, dass wir heute einen Bilderbuchstart erleben werden. Nochmals freut mich sehr, dass Sie zu uns gekommen sind, denn es ist ja kein alltägliches Ereignis. Specifically, I would like to welcome our American friends and colleagues, and specifically Professor Azra, the Associate Administrator of NASA for Earth Sciences. Mr. Azra, I'm very happy that you could manage to stay over tonight and stay with us and watch the events. So we are quite happy that you're here with your colleagues. Very welcome again. Meine Damen und Herren, wir werden also heute Morgen
I find that for some reason coffee just tastes better down here.
It's delicious on a nice day to enjoy the weather. A cup of coffee, it's beautiful.
I didn't come down here to vacation like I'm in Florida. That's right.
We can use satellite observations to understand continental scale changes of the ice in Antarctica. There are models which are basically an estimate of changes in volume of the ice on the continent of Antarctica. If you can imagine a satellite that observes changes in elevation of the surface of the ice through time, if that elevation increases, then you would expect the ice to be increasing in volume. But in reality, in order to know whether or not that elevation is really increasing in the ice, you need to know what is happening at the bedrock underneath, because you don't know if that surface elevation is due to changes in bedrock or changes in the ice.
At the GPS sites for the POLENET project, we're measuring how the bedrock moves.
We're looking to measure what is happening to the rocks, because the ice sheet models merely predict what's happening to the rocks. And we can't believe them. We can't trust them. We must make our own measurements.
Initially, we're principally interested in the horizontal motion of these sites. It turns out most of these sites are not moving very much in their horizontal, but we figured out that the vertical signal is very interesting here. Sites are moving up. As the ice disappears, the weight that's pushing down on the bedrock decreases and the bedrock rises. So as the ice goes away, there's less weight pushing down and the bedrock rises in response. And we're measuring very precisely how fast the rock is rising. So we'll look at a map and we'll go, well, what rock is sticking out, what mountaintops are sticking out of the ice, and we'll fly to the location and scout around from the airplane to look for what looks to be solid rock.
We're flying in such a mass area. We're trying to cover such a large continent, like a continent larger than the United States. The flying here, just in general, it's all off strip. You go to a site where no one's ever been before, and you got to create your own runway. And if something actually does happen, you're so far away from everything else.
It's really an age of discovery to be able to image the deep structures of this continent for the first time.
Well, I keep coming back because the questions aren't answered yet.
The only way to answer these questions is to learn more about the nature of what the ice sheet that we're currently standing on right now is actually sitting on. We don't know how thin the crust is. We don't know how hot the mantle is. We don't know if there's sedimentary basins down there which makes the whole ice sheet move faster. We don't know. And these are things that are absolutely critical in modeling the behavior of the ice sheet.